All right. Welcome back, everyone. Here for another live stream for the Battle of the Mine Hackers, our Bitcoin mining hackathon. I'm Stephen. I'm here today with Gabriel. How's it going?
Hey, Steven. Hey, everyone.
So, real quickly, I just want to kind of remind everyone about the uh, situation with the hackathon and all of that. So, let me just go ahead and pull up my screen here. We're going to talk about this for just a moment. This is your first live stream with us. This is a series of mentorship sessions we've been doing around Bitcoin mining. And this is part of a hackathon series called the Battle of the Mine Hackers. This is being put on by ATL BitLab. We are a freedom tech community space based in Atlanta, Georgia, in the USA. But this is a global event, so you can participate from anywhere in the world. The best way to get started is to go to atlbitlab.com and just click on the hackathon link. It'll take you here, and you can join the Discord from there. And that's where people are discussing their projects in the Discord, and mentors like Gabriel are there in the channel as well. And you can ask them questions about your project. I always like to thank our sponsors on this one: CleanSpark, Pleb Lab, Hash League, Choya Inc., and Cryobyte. We got 3 different prize tracks on this. A lot of times people think of hackathons as being just for coding and programming. That's certainly the case with this one. You can get involved in this hackathon working on minor decentralization protocols like Stratum V2 or Hashpool. And so it's very relevant to what we're going to be learning today with Gabriel. We also, however, have a track for hardware as well as energy. And so there's a 1.5 million sats prize for each of these, an ATL BitLab social pass, and a Cryobyte S19J Pro cooling kit. We also have a Hash League sponsor challenge. This is for the best new addition to Hash League, which is a community Bitcoin mining dashboard and leaderboard. You can learn more about our judges and our mentors here. Our schedule can be found on the website as well. I think we're approaching our last mentor session here, but we have several more builder jam sessions. So if you're here in Atlanta, you can join us in person, or if you're joining us from around the world, you can join on the video chat section on Discord. And the project submissions are due on July 1st. And then the finalists will be announced, and we'll do a finalist presentation and award ceremony and the days following that. So yeah, but like I said, best thing to do if you want to participate in fighting minor centralization, join the Discord. We'll help you find a teammate, help you get started on your project, all of that. So yeah, with that being said, I'm going to take my screen off and introduce you to Gabriel. So I met Gabriel at a conference earlier in the year and learned he was working on Stratum V2. And Stratum V2, and he'll tell you more about this, but I think this is a really important protocol for helping us to decentralize the mining pools that are out there. And that's why I asked Gabriel to come teach you all about Stratum V2. So Gabriel, thank you so much, and welcome.
Thank you, Steven, for inviting me. It's a pleasure. I always love this kind of initiatives, so really looking forward to see someone building stuff with my project. So I can share my screen and the slideshow I prepared. So yeah, before starting, I'm Gabriel. My nickname is GitGab19, almost everywhere. And I've been involved in the mining space for quite a while now. But then, yeah, I discovered Stratum V2 some years ago, and then I joined the project. So now it's been more than 2 years that I'm working on this, and I'm one of the maintainers of the project. So yeah, the agenda for today, before diving into the SRI, which is the project I'm working on, which stands for Stratum V2 Reference Implementation, I just want to give you a bit of context about the pooled mining protocols and the history behind them. Then we're going to dive into the SRI and see how the project is structured together. And then I can give you some tips about contributing, how to contribute to SRI specifically. And then we are going to put our hands on and get things started with the SRI, running all the servers, proxies, and the miners to see how it's working. So yeah, bullet mining protocols. This slide here is trying to capture basically the history about the bullet mining protocols. And the very first one was called Getwork, and it was invented in 2010, more or less. And it was like the first bullet mining protocol ever developed. And it was super simple, a simple JSON RPC method sent over HTTP. And it provided a pre-processed block header to work on to the miners. But it only permitted to do manipulation for the nonce research space by changing the nonce and the timestamp fields before sending a new request to the server. And that was the bottleneck, basically, of the protocol. That's why more or less 2 years later, two different ideas, get block template and Stratum, we can call it today Stratum V1, were developed to solve these inefficiencies. So get block template, also known as GBT, was very flexible, and it was solving part of the inefficiencies of the previous Getwork by letting the miner to manipulate other fields together with the nonce and the timestamp ones. But it was too complicated back in the days to be fully implemented, and especially together with get block template Slash, which was the inventor of probably the first mining pool ever in Bitcoin, which is a Slash pool, developed this Stratum protocol, which was way more simpler than get block template back in the days. And it was a JSON RPC protocol sent over plain TCP. And it was more efficient because of the push mechanism instead of the previous polling method used. And so that's mainly the reason why it became the standard de facto in the industry back in the days until now, which is currently used. By the way, it lacks some security and authentication measure for sure, and we're going to dive into that later. And it also introduced a centralization risk because of the fact that the only entities in charge of creating the block templates, so doing the transaction selection from the mempool, are the pool operators. So that's why 8 years later, more or less, the two founders of Brains, together with Matt Corallo, developed this new protocol, Stratum V2. They started to write a spec for this protocol. And yeah, Stratum V2 just solves basically all the inefficiencies and security problems of the current protocol, Stratum V1, by using an authenticated and encrypted protocol and introducing a binary framing instead of the inefficient JSON. And this is crucial in like saving bandwidth and make all the whole communication more efficient. But it also introduced a decentralization point, because with Stratum V2, miners can again do the famous transaction selection, and so taking a part of the power from the mining pool operators by doing that. The last point about Stratum V2, especially about SRI, which is the project I'm working on, is that it's very flexible. So we developed Stratum V2 as a reference implementation in a very modular way, and we are going to also dive more into this later. So here, this slide represents the current situation, right? With Stratum V1, the standard de facto used by the whole industry. And this is how it works. So on the right here, you can see there's a mining pool server, which is running the Bitcoin node. And thanks to that, it can create the block templates, sending then the mining jobs downstream to the miners. In some cases, there's a proxy in between them. The smarter miners, let's say, are using some kind of non-standard proxy to aggregate connections, but definitely the majority of miners are not running any proxy. So the situation is that for every machine, there's a connection directly open to the mining pool server, which is very inefficient. But yeah, the whole point of this slide is just to say that the Bitcoin node is run by the mining pool server. And so that's the only reason why we can see this chart on the right that I'm sure you already knew, which represents like the hash rate aggregated in the major mining pools. And that means that currently we have two mining pools which are covering 50% of the hash rate, more or less, if not more. And the remaining ones are like, many of them are not really pools, they are proxy pools. So they are like aggregating hash rate for end pool in most of the cases, or other larger pools. So the too long don't read here is that there's a lot of power in the mining pool operators with regards to the transaction selection process, which is crucial. And so we need to decentralize that, because censorship resistance as a property of Bitcoin is directly related to that. So if a government or anyone else wants to censor a transaction or a set of addresses, now it's pretty easy. The government just has to go to a couple of mining pool operators and tell them to blacklist a set of addresses. With Stratum V2, it's going to be different. So the transaction selection process is done by the miners. As you can see here in the left, the miner is running a Bitcoin D, a Bitcoin node, and together with other components like a translation proxy, which lets any SV1 firmware machine to communicate to any SV2 mining pool server, let the miner to build their own block templates and do the transaction selection process, and in this way decentralize the transaction selection process as a whole. So on the right, of course, there's a pie which tries to represent how the transaction selection distribution would be with Stratum V2 if all the miners, of course, of the majority of them would run their own nodes, building their own block templates. So after this initial context, we can dive into the SRI. Again, SRI stands for Stratum V2 Reference Implementation. We are just an open source project. We are not like an entity company or nothing more than just a FOSS project. And so here is how we are structured. We have many repos over our GitHub organization profile. And the first and the main one is the SRI, so the reference implementation. It's written in Rust. And you can, of course, dive into that, open the link at the bottom of this page, and you're going to see a lot of issues to be solved and many pull requests to be reviewed. So we always are looking forward to new people contributing to this repo. But together with the implementation, the other most important repo, I would say, is the so-called protocol specifications one, or just specs, which is basically containing the whole protocol specification. So if you dive into that, you're going to see the protocol overview, the security mechanism inside it, and the whole JD protocol, which is the job declaration protocol, which is the one used by the miners who wants to build their own templates. So I would really suggest to read the specs and then dive into the implementation, of course. So another project, another sub-repo of SRI is the benchmarking tool. I personally developed this together with a colleague of mine last year. And this is a tool which tries to benchmark the Stratum V2 and the Stratum V1 scenarios, making comparisons in terms of like latencies saved, bandwidth saved, and block templates value, and a lot of other metrics. And we recently published an article with the first case study done thanks to this project. And it basically wraps all the reference implementation repo that we saw before into Docker containers, together with some other metrics collectors and stuff. And if you want to like play around with this, I would really recommend, because it's probably easier as a starting point than the reference implementation one, and it's gonna give you like the whole overview about SV2 as well. Then finally, we have a fourth repo, which is just our website repository. If you are a front-end developer or whatever, feel free to open some issues here, or even better, open some pull requests to enhance our website. So yeah, I already mentioned something about how to contribute to SRI, but we can dive deeper into it. So in the main repo, the reference implementation, we have a contributing file, which is listing the major guidelines, let's say, in order to contribute to the project. So if you're really interested in doing that, take a look at this file. Then we organize, as a lot of other FOSS projects, through Discord. Mostly all the main communications are there. So if you want to join us, join our Discord server. The link is here, and we can also post it in the server of the hackathon as well. Then another point about SRI, which is very important, I mentioned before, SRI and Stratum V2 more generally is a modular protocol. So we can have different configurations. I don't know how much you can see here from the slides, but we can have configuration A, for example, which is basically the one in which the miner is running the Bitcoin node locally and is creating the block templates as well. And thanks to the translation proxy, the miner can easily use Stratum V2 with the usual SV1 firmware machines. So there's no need for SV2 firmware to be installed on them. Then we can see the configuration B, which is almost the same. The only difference, I'm sure you can't read from this slide, but the only difference is that here in between, we don't have a translation proxy anymore. We have a simple SV2 proxy, which aggregates the connection to make the whole communication more efficient. And the machines are running SV2 firmware. So that's why we don't need the translation proxy anymore. In this case, the miner is running SV2 firmware on their machines and is also running a Bitcoin node locally, creating their own block templates locally as well. Then we can see other two types of configurations on the right, in which maybe the miner is in a remote place with a poor internet connection or some like low bandwidth requirements. And so maybe the miner is not able to run a Bitcoin node, for example, or the miner is not interested in running the Bitcoin node and building the block templates. In this case, of course, the miner can still benefit from the improvements brought by the SV2 protocol without building the block templates. And of course, the miner can benefit from the encryption and from the binary framing, which is going to save him the bandwidth. And of course, it's going to secure the whole communication and their profits as well. So I would say that after reading the specs, understanding the different configurations and the modularity of the protocol as a whole, it's probably the best thing to do is to getting started with SRI and start playing around with the applications that we built as a reference implementation. And so you can see all the instructions on our website, stratumprotocol.org/getting started. And yeah, now we can enter like the more practical phase of this lesson today. So we can get started with SRI together, right? So as I mentioned before, if you go to stratumprotocol.org/getting started, you're gonna find all the instructions and the guide, which is gonna help you in running this specific configuration, which is like the most ideal one, right? The one in which the miner is running SV1 firmware, which is like the majority of the cases up to now, right? and the miner is running also a Bitcoin node, which in SV2 terms is called template provider, because it's gonna provide the block templates to the miner to work on. And then it's gonna run the translation proxy so that the SV1 firmware machine can communicate with the SV2 mining pool server. And thanks to the job declaration sub protocol here, the job declarator client, which is run miner side, is gonna be able to communicate with the job declarator server, which is run pool side, of course. So we provide two different ways to run this. The first one, I would say, is the easiest one, and it's basically just about running the already mentioned job declarator client and the translator proxy. After that, of course, the only thing remaining to do is to run the mining device. It can be a CPU miner, or if you have a real machine, of course, you can configure your ASIC to be pointed to the translator proxy and mine on it. In this case, of course, you are not going to run the template provider, so the Bitcoin node, nor the mining pool server or the job declarator server. You are going to use the one which are hosted by us as a project. But today, we are going to do the harder method together, which is running all roles. So we call roles what are applications. So the whole stack, basically. The mining pool server, job declarator server, the translator proxy, the template provider, which is the Bitcoin node, and the proxy in between. So the first thing to do, of course, is to download the patched version of Bitcoin Core from source, which is going to provide the SV2 block templates to the job declarator client. So you can go to this link here, and I would really suggest you to download the latest version here, 0117. You can find all the different binaries based on your architecture. I already downloaded it, of course. But yeah, this is the first step. So after doing that, since we are going to use testnet 4 now, you need to configure the Bitcoin node to use testnet 4, and you need to, of course, set an RPC username and password as well. After that, you can run, by following just the guide here, the template provider, the Bitcoin node, and go to the next steps. So we can start by doing that together. Here is the binary, which I already downloaded, and we can run the node together now. So as you can see here, I'm gonna zoom in a little bit. I specified, of course, that I want to use testnet 4. I specified SV2 flag as well, which is gonna say to the Bitcoin node to produce SV2 block templates, specifying the port used by the other roles. And the SV2 interval, this is a parameter which is gonna say to the node to produce a new block template every 30 seconds. You can also put like 10 seconds or whatever you want here. The SV2 fee delta here, it's another interesting parameter. If you set it to 0, you are going to receive a new block template every 30 seconds in this case. But you can also say, oh, I want to like work on a new block template only if the new block template has a fee delta with respect to the current one I'm working on of, let's say, 1 million sats or something like that. So as you can see from the logs, we updated our tip with the most recent blocks, and now we are ready to connect the other components. So going back to the guide here, of course, the first thing is to clone the repository. I have it already here locally. And then what we need to do is to run the SV2 pool. So all the applications are contained in these crate here roles. So we have the pull crate, for example, the JD client crate, the JD server, the translator, and so on. So now we need to run, the first thing to do is to run the SV2 pull, of course. And so we can open a new terminal here. And then, of course, here I'm already inside the roles, pull config examples, and then we can run it by specifying the config example.toml that we already provide, the one which is going to use a local template provider, since we are already running it. All right, so now the pull server is connected to the Bitcoin node, and as you can see here, it received already the first template. Then now we need to run the job declarator server, because when the miner is creating their own block templates, there's a job declaration process between the client and the server. And so pull side, what is needed together with the pull server is the job declarator server. So we have a crate for that as well. It's called JD server. You can enter in the same way the config examples folder, and from there you can run the usual command by specifying again the local example configuration, which is going to use the local template provider, the local Bitcoin node. After that, we can see everything is ready here. So the server is just waiting for new connections from the client. So if you go back to the guide again, this time we need to run the job declarator client that we already mentioned a lot of time here. So again, I open just another terminal, go to JD client, config example, and then from here, the usual command by specifying again the local example toml file. And here we can see that it's being connected to the job declarator server, and these messages specifically are the one defined by the job declaration subprotocol. If you want to know what's going on here, as I was saying before, the best thing would be to go to the specs repo and start reading more. So for example, the message here that we see is the allocate mining job token success. If you want to know what's that message, you go to the specs repo, you open job declaration protocol file here, and you're gonna see like all the explanation about job declarator server and what's going on, job declarator client and the same, and all the two different modes that you can do job declaration basically. But then you're gonna see all the messages, right? So for example, the one that we saw from the logs is the allocate mining job token success, and it's the answer sent by the JD server to the JD client to this previous message, which was sent by the JD client to the JD server. This was just an example to like help you navigating basically the logs using the specs, which is really recommended. But moving on, we already ran this job declarator client, so the only application needed to be run is the translator proxy, which will let us run an SV1 miner basically using the SV2 protocol. So I already entered this crate here, which is translator, and from here we can run the usual command by specifying the local job declarator client example file. So now the translation proxy is going to run, and it's going to communicate with the job declarator client, receiving jobs from that. So as you can see here, I hope you can read the logs. we received, so the translation proxy received a new extended mining job, which is again another SV2 term to say there's a new mining job which has been produced by the job declarator client using the local template provider or Bitcoin node. So everything is ready here, and we can finally connect a mining device. So of course, if you have like a BTEX, you can point your BTEX. If you have another ASIC, you can point your ASIC. If you don't have those, you can run a CPU miner. Here you can find some instructions to download one of them. This is probably the best CPU miner out there for GitHub, so I would really recommend to download this one. And I already did it, so let me clear this terminal. You can send this command here, which is gonna say, okay, let's run this using this algorithm, which is the one using in Bitcoin, used by Bitcoin, sorry. And then you can specify here the port, which is the one where the translator proxy is listening on. So as you can see here, we have been connected to the translator proxy. The first messages here are the usual ones, the subscribe, the authorize, and then we received from the T proxy the Stratum V2 message containing the job, which is this mining notify message. So after that, of course, the CPU miner starts to hash on this job, finding shares. So if you go back to the T proxy or translator proxy logs, you can see we are receiving shares from the downstream miner here. And of course, some of them are going to satisfy the pool difficulty, and they are going to be relayed by the T proxy to the pool as well. So on the right here, just to give again better context, we have the translator proxy, which is translating the SV2 jobs into SV1 mining notify messages, basically, and the SV1 mining.submit, which are the SV1 shares, into SV2 shares to be sent upstream to the pool. On the left here, we have the job declarator client. So as you can see, for example, here, the job declarator client just received a new template from the Bitcoin node. And after receiving the new template, it created a new job, which was received around here by the translator proxy. So this is the flow. The Bitcoin node or template provider in SV2 terms creates a new template. The new block template is received by the job declarator client, which is in charge of creating the mining jobs, which are then sent and received by the translator proxy. And then finally, the translator proxy, every time it receives an SV2 job, it just translates it into an SV1 mining job, sending it to the SV1 miner, which is connected. And then if you want to see like what's going on the pool side, here are some logs. So on the right here, there's the job declarator server, and this is the application which is communicating with the job declarator client. And as you can see here, it's constantly receiving messages from the job declarator client, such as the declare mining job, which is basically saying, hey pool, I'm gonna work on this mining job, right? And then on the left, there's the pool server logs. And as you can see exactly here, the pool server just received a share from the miner, right? So that means that the miner produced a share which was satisfying the pool difficulty. And as we can see here together, we have also a log for that. So whenever you're gonna read share meets upstream target, that means okay, the share which satisfy the pool difficulty has been found, and that share is going to be relayed to the SV2 pool, and you can notice that by reading the logs similar to these ones. So here is how to run the whole SV2 stack using your terminal, and you can basically, again, just to recap, create your own block templates using an SV1 miner connected to an SV2 pool, thanks to the translation proxy. So I just want to repeat this because I heard many times on Twitter and similars that SV2 is not usable yet because it needs SV2 firmwares to be there. But that's not the case. We developed as SRI the translator proxy exactly because of this. So you can easily run everything which is needed to let your miner build the block template and be connected to an SV2 pool, even if you're running a normal SV1 firmware on your machine. So I'm gonna go back here to the slideshow. This was almost everything. So again, on the website, you can find the instructions and try to run everything as we did together now. Here, just some references. Again, to better understand how the SV2 protocol works, I really recommend to read the specs. You can find the link here. And then, again, start to run everything as we did together by following the Getting Started guide on the website. And if you want to dive deeper into the whole mining protocol, pooled mining protocols, history and evolution, and reading more about SV2, I did a master degree thesis on that, and you can find it on my GitHub repository, which is linked there. Or you can just also go to YouTube and watch the beautiful playlist made by Plebesh, which is another SRI maintainer, which is basically gonna give you the whole context around the mining, the pooled mining protocols, and SV2 specifically SRI. So I don't know if we got some questions while I was speaking or not. I'm happy to answer to some of them eventually.
Hey, thanks, Gabriel, so much. I did not see any questions come in the chat here, though we do have a good many people watching here on X. I did have some questions I came up with. I was curious if you could explain differently the job declarator client versus the server. What's the difference between those two roles?
Right. So as I told at the beginning, SV2 is modular. So you can use it by benefiting by the security measurements and efficiency measurements, which are brought by the encryption that we introduced or the binary framing that we introduced by the protocol, without having to run your local Bitcoin node and without creating your block template, because maybe you're a miner which is based on a remote location with a poor internet connection or anything similar, or you want to save bandwidth, or maybe you just are not interested in doing that. So in that case, you just need to run the translator proxy and point that to an SV2 pool without having to deal with these all JD clients or servers. If you want to build, of course, your block templates, and that's the best scenario for SV2, of course, you need to run this job declarator client miner side, and the pool has to run this job declarator server pool side. So that's just because when the miner creates the templates, we need like to say to the pool like how the block template is built, so that the pool is also able to propagate the block eventually when the miner is going to find it. So I haven't said this, and it's very important. By running the job decorator client miner side, the miner, whenever he finds the block is going to be propagated miner side as well, thanks to the job decorator client. The job decorator client is always connected to the Bitcoin node, which in SV2 terms is the Bitcoin, the template provider. Sorry. So job decorator client is going to create a block and submit that to the network through the Bitcoin node, which is local as well. But at the same time, there's a dual block propagation, because the pool can also propagate the block as well. And the pool needs some information, and this information to rebuild the block before propagating that into the network. And that information is sent by the job decorator client to the job decorator server at the beginning. So all the messages, I mentioned a couple of them, like allocate mining job token or declare mining job. Those are the messages which are exchanged by the miner and the pool, specifically by the job decorator client and the job decorator server, so that also the pool is able to propagate the block when the block is found by the miner.
So it sounds like, let me see if I understand. So the mining pool would only need to run one job declarator server, but any cluster of miners that is joining that pool, if they want to control their own block template, they would need to run their own job declarator client.
Exactly. So in the same way, the pool server, the usual pool server, is like the server run by the pool, and all the miners are like connected to it. In the same way, for the so-called job declaration protocol, which is this sub-protocol which defines the way the miner can create the block templates, basically, we have a server which is run pool side, and then every miner is going to run the client miner side to be connected to this server, for example. Because I haven't mentioned this, but again, it's very important. What the server, the job decorator server, needs to do is basically to send to the client, for example, the Coinbase output, where the reward of the pool has to be sent, right? Because of course, this information is something that if you want to do pooled mining and you want to create your block templates, the pool needs to send you like the address, the Coinbase output to be put in the block template, basically, to collect all the reward of the block. So these are other two messages defined again in the job declaration subprotocol. And then of course there are some other details which can be read by the on the specs repo specifically.
That makes sense. Thank you. And I guess also for the SV1, SV2 proxy, I guess we need that because all the mining hardware we have from Bitmain, for example, is all SV1. And so in the future, maybe if miners started being manufactured with SV2 support natively, then we could just cut that part out of the stack.
Exactly. At that point, we can also run a proxy, in the sense that we will have an SV2 proxy, pure proxy, which is gonna maybe aggregate the connections, because that's also another important thing. Instead of opening one connection for every machine that you run as a miner directly to the pool server, you can aggregate all the connections into a single one, so that you're gonna save basically a lot of bandwidth, and the overall operation is just more efficient. But that's gonna be, of course, optional. And we are not gonna need the translation process, basically, which is what the translator proxy does nowadays.
That makes sense. And tell me about the Bitcoin Core, the fork from Shores. Is this like strictly necessary to run that version of Bitcoin Core, or is this like a pull request that y'all are hoping to get merged in?
Yeah, I mean the process related to template provider and the introduction of SV2 into Bitcoin Core is very long. There's a lot of to be said there, but yeah, we started to by saying, okay, we want to integrate SV2 directly into Bitcoin Core, but then of course it was not something ideal as a long-term solution, because that code has to be maintained, of course, and Bitcoin Core developers already has, you know, something to do, right? So now that's why we have this patched version of Bitcoin Core, which is able to create SV2 block templates. But this is just a temporary solution. Theoretically, after the new release, which, if I'm not wrong, is going to be like the 0.30 release or something of Bitcoin Core, they are going to ship new interfaces related to mining. And using those new interfaces, we can basically run everything without the need to run a fork of Bitcoin Core, basically. So we can integrate the SV2 protocol, let's say, in the block template creation process without the need to run this fork, which is currently maintained by Source, which is, by the way, one of the most famous, let's say, contributors of Bitcoin Core. But yeah, ideally, that's the long-term solution, right? Because of course, running a fork of Bitcoin Core is always like, oh, what I'm running, I don't know, I don't trust anyone. So it would be better, and we're gonna do that in the future after the new release is gonna come from Bitcoin Core. You can easily run your Bitcoin node without having to specify any SV2 flag, for example, when you run it. And yeah.
All right, that makes sense. Thanks so much. I had some hackathon project ideas for people while you were giving your presentation, and I'll share them here. Maybe if you have any ideas, you can share them, or let me know if my ideas are bad and don't make sense. But one thing that occurred to me is that you have all these different roles with Stratum V2, and it's modular. What if somebody were to take the SRI and package this up for Start9? So it could be something on the Start9 community marketplace. It could be like a one-click install, and there could be a menu configuration option to, you know, turn on the job declarator client and connect it to the Bitcoin Core node that's already running on your Start9.
Absolutely. I mean, that's just a great idea. That's what we need, actually. But we are a small team, and now it's like our priorities are others. We are like basically transforming all these applications, like the pool server, the proxies, and the job declarator server and client, whatever, into a production ready state. So we are focusing there.
I want somebody who's watching this to build that for you.
Yeah, exactly. That's what I was going to tell. Yeah. Exactly. I mean, that's in our plans. It's just that we are not there yet. If someone has the time and wants to do that, it would be just great.
And some other ideas, not with SRI, but at least with Stratum V2 spec. There's another very popular package called Public Pool that is a TypeScript implementation of Stratum V1. And it runs, there's a Start9 version, there's an Umbrel version, you can set it up yourself. I think it would be fun if somebody forked or made a PR of Public Pool and tried to implement Stratum V1. And I think it could be, you know, I'd be curious to see if somebody could take an agent and feed an MCP server like the Stratum V2 spec and the Public Pool repo and vibe code a, you know, really super rough, you know, version that uses Stratum V2.
Yeah, that would be cool to see.
And the final idea I had was, we have, you know, one of the problems that occurred to me with well, right now we need to use the SV1, SV2 proxy, which is perfectly fine. And that keeps all of our Bitmain miners running. But then we have the BitAxe, which, you know, obviously not much hash rate, but we have a lot more control over that firmware, I believe, because the printed circuit board is all open source and the BitAx OS is open source. So I wonder if somebody familiar with BitAx OS could fork that and make it compatible with Stratum V2 natively.
Yeah, this is something that we worked on. Actually, some months ago, there was a guy who contributed a lot actually to the BitAx firmware. I don't remember his name, unfortunately, now. But by the way, he made all the lower level crates to implement SV2 no STD compatible. And that means that all the lower level crates, they can be run on like everything, basically, with very low computation. So that was like the first step to allow something like you said, to implement basically SV2 on the BitAx firmware. So theoretically, we have all the pieces there. Yeah, I haven't dived enough probably in the repo, but what I'm mentioning now, like with lower level crates and all the pieces, is contained under the protocols folder. So if you go, we explore together the roles because we wanted to like run the applications and see the whole communication. But if you want to like build something like you said, the BitAx firmware or whatever, you need to pick the lower level crates, which are gonna give you like the APIs or something that you need to implement the firmware from the protocols folder. So go there. We should have already all the pieces needed. So that would be just great.
Yeah, so then the lower level crates are there. So if anyone watching is familiar with the BitAx operating system, and you're not afraid to touch some Rust crates, then the building blocks are already there for you to go and build this stuff.
Yeah, exactly. I mean, we would be just pleasure to see that happen, because we put a lot of effort during last months actually in documenting all these lower level crates so that people could like take them and ship something. So really looking forward to also feedbacks or bugs or issues opened on the repo for that. So that would be cool.
Yeah. Awesome. Well, I don't see any other questions. We got a comment from Digital Technologies, timely info because I've been wanting to set up a pool. So yeah, definitely rewatch the stream, Digital, and learn all about how to set up SRA. Gabriel, thank you so much for giving this presentation for everybody. And if anybody watching has any questions, you can probably find him on Discord.
Yeah, absolutely.
All right,
Thanks to you,
thanks you.
Stefan.
Enjoy the rest of the day. Bye.
Bye-bye.